Hi, this is Jack from Maths Forge, and in today's lesson we're going to be converting fractions to recurring decimals. So the thing about recurring decimals, they are decimals that do not terminate, so they go on for infinity, but they recur, they repeat. So 0.353535, and if that goes on forever, is a recurring decimal. A quick way of writing this would be 0.35 and then 2 dots on top. Another example of a recurring decimal is 0.405, 405, 405. And a quick way of writing this would be 0.405 and the recurring dot on top of 4 and on top of 5. So this means that the numbers from 4 to 5 will keep recurring. Now, converting fractions to recurring decimals, there's something that you should be aware of. Number over a 9 or a 99 or a 999 will recur. So for example, if I have 5 over 9, since there is one 9 at the bottom, then the recurrence here is going to be 0.555, and it's just going to keep on going forever. So this is going to be 0.5 recurring. Now for 52 over 99, since there are two 9s at the bottom, it's going to recur with 2 digits. So it's going to be 0.52, 52, 52. So my recurring values are going to be 2 digits because there are two 9s at the bottom. So it's going to be 0.52 recurring. And of course, the same idea applies if there are 3 9s at the bottom. So if we have 146 as an example, then it's going to be 0.146, 146, 146, and that keeps recurring. So a quick way of writing this will be 0.1 with a recurring dot on top of 1, 4, and then a recurring dot on top of the 6. So now that we know if your fraction is over 999 or 999, then it's going to output a recurring value, we should try to get whichever fractions we're given to become a value over 999 or 999. Notice as well that if you have one digit at the bottom, that's a 9, then having one digit at the top, which is a 5, will cause this simple recurrence pattern. But what about if we had one digit on top, but two 9s at the bottom? So what if we had 5 over 99? Well, we have two 9s at the bottom, so technically we should be having two values that recur. And we do. Our two values that are going to recur are going to be 0, 5. Since 5 written as a 2-digit number is 0 and 5. So this is going to give us 0.05, 05, 05. Or a quick way of writing that would be 0.05 with the 2 recurring dots over the 0 and the 5. So just be aware of that example there. Now let's use this knowledge to answer our first question. Here we're being asked to convert 46 over 99 to a decimal. Well, from our previous explanation, we can do this by simply writing 0.464646. And of course, a quick way of writing this is just going to be 0.46 with the 2 recurring dots over the 4 and the 6. Since there are two 9s at the bottom, then there are going to be 2 digits that are recurring. And since there are 2 digits on top, they are the 2 digits that are recurring. So if we check our answer, there it is. Let's do another 1-star example. So here we're being asked to convert 8 over 9 to a decimal. So of course there's one 9 at the bottom, so there's only going to be one value that's recurring. And since we only have one digit on top, that is going to be the value that is recurring. So let's write this in a quicker way. It's going to be 0.8 with a recurring dot on top. And if we check our answer, there it is. Now if we do another 1-star example, we have 6 over 11 that we are to convert to a decimal. Remember what I said, if it's over 999 or 999, it's pretty straightforward. So I'm going to get this 11 to become a 99 by multiplying it with 9, and I have to do the same to the numerator. This now gives us 54 over 99. So manipulating the 6 over 11 to get it to become a fraction over 99 is going to help us tremendously. Now that we have 54 over 99, I know this is going to be 0 point, and then there are going to be 2 digits that recur because there are two 9s on the bottom. And those 2 digits that recur are going to be the value of the numerator. So it's going to be 0.54, 54, 54, and this keeps on going on. And of course, a quicker way of writing this is 0.54 with a recurring dot over 5 and 4. And if we check our answer, there it is. Other fractions that recur are also 1 over 3, which recurs to 0.3 recurring, and 2 over 3, which is going to be 0.6 recurring. So we can actually use these fractions to decimals to help us answer this 2-star question. Here we're being asked to convert 8 over 12 to a decimal. So 8 over 12 can actually be simplified. And it can be simplified by dividing the numerator and the denominator by 4. So I'm going to go ahead and do that. This is going to leave us with 2 over 3. And of course, from the previous explanation, 2 over 3 as a decimal is going to be 0.6 recurring. So 0.66666, and that goes on forever. And if we check our answer, there it is. We'll do another 2-star example. Here we're being asked to convert 5 over 6 to a decimal. Now, since it's over 6, we have a problem. We can't multiply this 6 by any number to get it to become 99. So we can't find an equivalent fraction that can help us to find the recurring decimal easily. Also, we can't simplify 5 over 6 further to give us a fraction that's over 3, which will also give us an easy way to find a recurring value. If you are presented with such a case, the only real way to convert this fraction to a decimal is to use the division method. And in this case, I'm going to use short division. So I'm going to divide 6 into 5. And of course, 6 goes into 5 0 times with a decimal point there. And because we haven't actually broken up this 5, we're going to carry it over, putting 0 as a placeholder. Of course, if I do my 6 times tables, 6, 12, 18, 24, 30, 36, 42, 48, and then 54. So if you go up in your 6 times tables, how many times does 6 go into 50? Well, it goes into 50 up until this point here. 1, 2, 3, 4, 5, 6, 7, 8 times. So I was correct. And the remainder is how much you need to add onto this final value to get to 50, which is 2. So it's going to be remainder 2. And 6 goes into 20, 1, 2, 3 times, with a remainder of another 2. And you can see that the recurrence is going to start. So then that's going to be 3 with another remainder of 2, and so on and so forth. So 5 over 6 converted to a decimal is going to be 0.83 recurring. So if there are no quick methods to convert the fraction to a decimal, your best bet is to use the division method. So it's very handy to have one ready. Now we'll do a 3-star example. Here we're being asked to convert 3 over 7 to a decimal. So that's going to be 7 dividing into 3. 7 goes into 3 0 times with a decimal point and a placeholder of 0. Remainder 3, because we haven't actually broken up this 3. Now 7 goes into 30. If I do my 7 times tables really quickly, 7, 14, 21, 28. And I know now I'm going to skip 30, so it goes into it 4 whole times with a remainder of 2. And that's going to give us 20. 7 goes into 20. Well, I know it's going to go into it 2 whole times, as I have 2 numbers before 20. So it's going to be 2. But with a remainder of 6. And now 7 is going to go into 60. Well, if I carry on with my 7 times tables, this is going to be 35, 42, 49, 56. And I know the next one's going to skip 50. So it's going to go into 60. 1, 2, 3, 4, 5, 6, 7, 8 times. With a remainder of 4. And 7 goes into 40. Well, we can count this. 1, 2, 3, 4, 5, and then it skips 40. So it's going to be 5. Remainder 5 to get to 40. So it's going to be remainder 5. And now 7 goes into 50. 1, 2, 3, 4, 5, 6, 7 times. Remainder 1. So 7 times. Remainder 1. And now 7 goes into 10. Once. Remainder 3, because 7 goes into 10 once, and then you need to add 3 onto the 7 to get to the 10. And now we're back at 30. This was a pretty long-winded conversion. So there is something to notice here, though. And let me just actually write this down here. So I know that 7 goes into 30 4 times, and then it's going to repeat. So from the 4 to the 1, there is no repetition. But after this, we can see from the number we're dividing into, this 30, that it's going to repeat. Of course it's going to repeat. If dividing 7 into this 30 here cause these sets of numbers to appear, the next time it goes into a 30, it's going to cause them to reappear again. So I guarantee you that if we carry on with this division, we're going to end up with a 2, 8, 6, 5, 7, 1 after this 4. So now I can safely say that 3 over 7 written as a decimal is 0.428657 with the recurring values over the 4 and over the 1, because beyond these numbers or beyond the 1, it's going to repeat again from this 4. And if we check our answer, there it is, 0.428571 with the recurring values over the 4 and the 1. And that's it for our lesson on converting fractions to recurring decimals.